So if you wanted to get into the field of forensic science, or maybe you watch a show Dexter like me, and it seemed very interesting to me, especially blood spatter, which is what he does in the show. And I want to do this when I get older. I'm currently taking entomology right now, and I am going to minor in forensics next semester. My name is Nick Williams, and today I'm going to be showing you the different types of spatters that come from a crime scene and different types of procedures that they go through to be able to analyze certain things. So you may be wondering, what is bloodstain pattern analysis? And it is the study of the size, shape, and location of bloodstains in order to provide an interpretation of the physical events in which gave rise to their origin. So my uncle is in forensic science field, and he has taught me a lot about forensic science, and especially this blood pattern analysis, because that is what I want to do. I've seen him do many caseworks that I've been to his job with him, and I learned a lot from him. And I've studied a bunch of this stuff over the past year and a half or so, just because I want to be able to know what I'm doing. And when I get into class, I know what I'm doing as well. And so for this first thing I'm going to show you guys is what the angle of impact is. So when force and impact is applied on a source of blood, an impact pattern is created around this event. And this is called the angle of impact. And that is the acute angle formed between the direction of a blood drop and the plane of the surface that it strikes. After the impact, the resulting blood droplets move through the air like a sphere, and that creates an ellipse once that hits the surface. The formula for determining this are shown in this bottom right photo and this bottom left one. So basically what you want to do is once you get the blood stain, you want to take the length and the width. So you got 18, 9. So what you want to do, you want to take the sine of the width over the length. So it'll be 9 over 18, or the sine of 9 over 18, and you will get 30 degrees here, which gives you that angle of impact. And for these two photos right here, these other two photos, these were patterns created with a hammer. And these are not real crime scene photos. These are just taken in the lab. So the blood originally was on that little log of wood. So they hit the hammer on the blood, and that made all those different spatters. And you can clearly see the variation in size. In the location where the blood spatter is more or less round shaped, that gives an indication of the height where the impact on the blood source has basically taken place. So for this one, this is the area of convergence. The area of convergence is determined by drawing lines on a two-dimensional surface to the axis of blood spatter. The areas where the line intersects is most likely location in which an impact in the blood has taken place. This is for a murder case, which is shown here on the bottom right, and it happened on a couch. So the area inside the red circle on the wall where the lines intersect, that is basically the appropriate height at which the impact of the blood of the victim took place. And that green line represents the top of the couch. This left photo here, this is basically where the blood of the drops hit the wall is determined here. The green line represents the top of the bench of where the victim was laying. And the area of origin is where these lines here intersect inside this red square. And in this three-dimensional space, the impact on the blood of the victim most likely occurred here. So for this one, the geometry of spatter. So basically, traditionally practitioners of blood pattern analysis trace a straight line from the stain at the impact of the angle to reveal where the blood originated. So this correctly maps the path along the floor here for the gray lines, horizontal path of origin here. You got the straight line trajectories, are these dashed lines. And those overestimate the vertical height of the impact because the blood would have taken place on a type of modified path on these blue things, and that is due to gravity and drag. And for most of these types of analysis, you really want to avoid being lazy, because if you're lazy when analyzing, either one, you're going to incriminate someone that is not guilty because you didn't take the time to actually look into it further, or two, the whole entire evidence is just thrown out of court because you were too lazy and it's just not good work, and they won't use it because it's not good work. So here for the first type of spatter we have here is for a shooting incident. So let's take, for example, in this photo, someone shooting in the head, it creates back spatter and forward spatter. Back spatter is blood directed towards a source of energy or force that causes spatter. As you can see here, you shoot and it comes back at the shooter, and then you have forward spatter. That travels along with the bullet to the opening where the bullet leaves the body. And these usually contain more blood than the back spatter, as you can see here in this little visual. Next, we have cast-off spatter. So cast-off spatter is patterns that are projected of blood when an object such as a knife containing enough blood is swayed in the air. Cast off spider is a bloodstain pattern created when blood is released or thrown from a blood-bearing object in the motion. Basically the same thing. So for example, if someone were stabbing someone, they would go in and they'd keep taking it out and going back in. And once it takes it out, blood will fly off the knife and hit the wall. That'll be cast off spatter, as you can see here in this little photo. Whenever people are wearing clothes, there's not as much spatter because once you go in and you take it out, the blade kind of rubs on the clothes, so it takes a little bit of the blood off. So that is kind of something like that. This photo here was created from someone just putting blood on their hands and flinging it against the wall. For the next one, we have wipe and swipe patterns. So a swipe pattern is the transfer of blood from a moving source onto an unstained surface, and the direction of travel may be determined by the feathered edge. And then a wipe pattern is a bloodstain pattern created when an object moves through an existing stain, removing and or altering its appearance. So these photos are one of someone who was being dragged by the perpetrator, and then the other one is where someone was walking through the bloodstains with socks on through the wet bloodstains. For this next one, we have a really big thing that is very important in analysis, and that is luminol. Luminol is a chemical in the presence of a bluish light. It'll kind of light up whenever you spray stuff with it, as you can see here in this photo. And a lot of it is not visible to the naked eye. Like in this left photo, you see nothing, but in this right one, after they sprayed it and shine it with the blue light, all that blood pops up. It can react to other things such as cleaning stuff, like let's say chlorine, metals, and other certain substances. They can have false positive reactions, and they may be excluded using a more specific blood test, something known as the tetra base test, which I can't get into that, but that is another test that helps with that. As you can see here, when a small amount of blood is cleaned with water, luminol can create an image where it seems like a much more blood has flowed. So it's kind of hard to determine that, but because of the sensitivity of luminol, quantities of washed away blood can cause strong luminescence, and this tells us more about the blood that is lost by the person, basically. These are my citations, and I hope that by the end of this video, you may be interested more in forensic science and you are able to learn more about the different types of patterns and the type of procedures that go in. And I hope you all enjoyed. Thank you.